So at first, so let me see, what is our object today? So in this class, today's class, we are going to learn at first the concept of topographic drawings. So that is what is the topographic drawings, and the representation of the slope. It's a important step to draw the photography drawings, and how to get the intersection line between two different slopes. So usually we see we can see the kind of map like this, So so I have show it before in the AutoCAD lessons. So you maybe you remember in which part I have shown it to you. I think at the class about the layers, really. In that class, use the contour maps as an example to show the layers, the function of layers, and how to use the layers. Okay, so maybe we don't have to draw these irregular curves to represent the shape of the ground. So, but we have to know how to read this, how to read, and how to draw. And we don't have to draw it by hand. But because this is for the irregular ground, irregular shape, irregular shape. But as for some regular shape, for example, the plane of the cone. So we have to draw it by hand, by your pencil, by your ruler and compass. Okay, so now you can see so the contour maps, you can see there are many circles, and many points with a number on it. Okay, so that is the contour maps, and I will illustrate more detailedly in the follows. Okay, so the first one is introduction of the topographic drawings. So at first, so the first question is why? So why we have to use the topographic drawings? So who can tell me? Who can give me an answer about this question? So why? So I think now you can image you can image in your head, in your mind. So if you okay, so who want to? Yes, Mongo.
The reason why we draw topographic drawings.
Yes, about the reason why we have to use the photographic drawings.
To represent its surface and features accurately using a scale.
Okay, to represent the shapes and the features of the ground. Ready? Yes. Okay, so let me think about how to represent. I think we have learned a lot about the different wheels. Maybe you will remember the front wheel, the left wheel, and the top wheel. Yes, so we have learned these three directions. Yes, these three directions. And now please imagine that if there is a mountain in front of you, or there is a irregular irregular shape of ground in front of you. For example, a valley, the valley, or a river, or a cliff. So it's very hard for us. I think it's very hard for us to draw its to draw the front view of a mountain and a left view of a mountain, because you don't know so because it's very complex. So it's not like a cube. It's not like a rectangle. It's not like a sphere. So you can see a simple shape in the front, in left, and in the top. So as for the irregular shape in the mountain on the ground, so we have to use the top view, just top view, to show the shape, to show the position, and to show the elevation. So that is why we have to use the topographic drawings. I'm not, I don't know. So if you can understand, for example, if you want to draw a map, a mountain on the ground, and you can't draw the front view. But as for the top view, I think it's much easier for you. Yeah, so we have to use the top view, to represent the features of a mountain, and the shape, and some details. So we can use the top view. We use the top view. Okay, so let's see. So so in the civil engineering, it's often necessary to draw the topography maps in order to we have to describe and solve the related problems on the drawings. And because the shape of the ground is very complex, there are many mountains, there are many rivers, and so on. And so usually we use the horizontal sides and the different from the height sides, so it's very difficult to express it clearly with the multi-phase or orthographic projection. Orthographic projection. So I have answer for the first question, why, and the second, so what? So what is the topographic drawings? Topographic drawings is a horizontal view which man-made features a vision to represent the object. So we have to use you can imagine a mountain, and we use a horizontal plane and cut this mountain in the different elevation, and we can get the cross section, the cross line of the horizontal plane and the mountain. So that irregular curve, we call it the contour. And now we can see how to draw the contour maps. The contour maps including three parts. So at first is the horizontal wheel. Draw a horizontal wheel. It means that you are looking at this ground from top view. horizontal view. And with the man-made features elevation, man-made features elevation is the curve, irregular curve you have seen in this map. Here is the man-made elevation, and this point is also man-made. And the second one, we have to use the scale. Why we have to use scale? I will tell you about this in the slope in the slope part, and scale used in the horizontal view. So we have to know the actually distance between the different point from top view. So based on the factors above, we can describe object in 3 dimensions. We can describe it accurately. And okay, next one. So that is the way you can see that is the way to get the topographic drawings. So you can see here is like a mountain. Oh, okay. Here is like a mountain. You can see, and here is the base plane. The base plane is means we have to we are going to get a projection of this object, this project. So in this plane is the top view of this mountain, and you can see there are many different layers. The first one is you can see there's a number. Their number is 15. 15 means this elevation is 15 meters. 15 meters, and above the 15 is 20. 20 meters. 20 meters. It means that this plane, this plane's elevation is 20, and about 20 is 25 and 30. And of course, if you want to cut this mountain into many parts, you can use you can also use the 15 and 16 18 17 18 19 20. You can add more cut planes to get more contours, so it will make your drawing more detailed. But also you have to do more work, and it's not efficiently. So so whatever you do, you have to keep a balance between the efficiently and the detail and the accurately. So now we can understand how can we get the topographic and the topographic drawings, and you can see this contour. This contour is equal to this line. This line is the section line between the cutting plane and the real object. And this one, this line is equal to this line. This line, and then this line is equal to this line. This one is the same. And you can see there is a feature about the topographic is they are closed. They are a closed circle. they are closed circle, but not a irregular circle. So if there is a cone, if there is a cone here, if there is a cone here, not a irregular shape, so please tell me what we will get. What will we get in this map? So who can tell me if there is a cone? So okay, so now let me check about first one, Hubin, Abdullah, Hubin. Hubin is not here. Okay. Next one, okay, the Jianli, Sarma Jianli. So if there is a cone here, so what? Yeah, if there is a cone, C-O-N-E. Okay, so let me see. Yes, for example, if there is a cone here, if there is a cone, and so what we get? So we will get several circles with the same center. Okay, I think it's very easy for you to understand this question. Okay, so the next one is the pyramid. So in this page, we have seen the mountain and a cone. So in this shape, in this page, we are going to see a Caudry pyramid. So please think about if I have this pyramid, Caudry pyramid. So I want to use the top view to determine the position and the shape. So how to do it? So I think if you want to determine Caudry pyramid, at first you have to know the height of this pyramid, and the shape of the bottom rectangle and the top rectangle is so we can see it clearly in the top view, like this one and this one. So we know the top, we have no top and the bottom, and the problem is the height. So how can we get the height of this pyramid, Caudry pyramid? So now we have to use the man-made elevation. This one means this plane is the elevation of 2 meters, and here is the zero. It's the zero elevation. And here you have to use the scale, the scale ruler, to tell others the length and the width of this shape. Okay, so that is a way to represent Caudry pyramid. So so if I get this map, this figure, I can draw the the real things. I can draw the real things. So that is and that is the example. That is the example. Okay, so from this example, so we are see, so maybe you will remember in this map, you can see there is 289.4, and there are many points, many irregular lines. But so, what is the meaning of this number of this number? So now I'll tell you, this number represents the elevation of this point. So the elevation is the vertical distance from here to the sea level, and also so there are many many ways to determine the this number, the elevation point, and so here we call the original data point is the geodetic datum. So in many countries, they have different geodetic datum. So as for this, here is the geodetic datum in America, and this one is in Australia, and this one is in France, and this one is in Japan. And also, maybe you can check, you can search where is your country's geodetic datum. So every country has his own, because they have to measure, they have to draw the maps, they have to draw the contour maps of your country, So we need a geodetic datum to draw the elevation. And as for China, the Chinese datum elevation geodetic datum is in a city called Qingdao, and here is and this one is the zero data, sea level is elevation is zero. And so in each mountain, so every mountain, every features of geometry of geology are based on this level. For example, as for this map, you can see the number, and this number is the difference in the vertical direction, the difference between this point to that point, to that point. So now, yeah, you understand what's this meaning of this number, the meaning of this number. So okay, now we know how can we draw the contour maps, and how to determine the elevation number, and now we know we have to use the geodetic datum to get every elevation point. Okay, so now you can see there are many. So let me see the features. The features of the contour maps. So now you can see here is several mountains and the rivers and here is a cliff and here is a plate. There is a top and here is a valley. Here is a valley and here is a rigid uh, rigid of a mountain. So each 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 part we can see in the contour maps. In the contour maps now, for example, this circle, it means the top. It is the top, and here you can see many circles, many close circles together. It means here is the top, and you have to check this elevation point is larger than here. So because here is the elevation of this point is bigger than here. It means you have if you are sitting if you stand here and you want to get there, you have to climb the mountain. You have climbed the mountain, and from here to here, you have to go down. You have to go down. So, but if there is also a circle and a circle, so but if this place is larger than the center, so what is the shape? What is the shape? It's like a V. It's just like a V. So let me draw it. It's just like a V, and okay, if you if uh, if this point is bigger than here, it's a mountain. It's a mountain. So we can see many shapes of the ground we from the contour maps. So from the contour maps. Okay. And so we have learned about the contour maps, and the next one is the uh, point on the topographic drawing and on the topographic drawings. The first one, the most simply one is point. So so we can use many point to represent a line. So at first we have to study about the elevation of the point. So how to represent an elevation of a point? So at first we have a plane, and this plane's elevation is 0. This plane's elevation is 0. Is 0? 0 of this plane. And you can see there is a point A. This point A's elevation is 5 meters. It's 5 meters. So how can we represent this point in the top view of this plane? Now you can see here, and in your right hand, you can see the A5. At first, you can write the name down, A, and this figure is 5. This 5 is this 5's meaning is 5 meters. This vertical distance is 5 meters, and here. So please tell me, where is the C? So who can tell me where is C? You can see the C's elevation is 0. So where is C?
C.
Who can tell me where is C?
It's like the sea level.
Yes, at the sea level, and in this plane, you can see sea is red on this plane. So its elevation is 0. And how about the B, the -3? Where is B?
Lower
Okay,
than
so
the sea level.
yes, so you can see B is lower than the sea level. So usually, uh, so many students ask me, so why, where can we get the minus level? So usually we think what where we are is below the sea level, is above the sea level, is above the sea level. Um, but in some place in the world, there's many places below the sea level. For example, in Netherlands. So Netherlands, most part of Netherlands is below the sea level. Do you know?
Yeah.
Yes, because there is many dams around the Netherlands, and to keep the seawater to keep the seawater outside the mainland, outside the land of Netherlands. So Netherlands is a country under the sea level. So if you if you draw the contour maps of the Netherlands, you you are always you will always write the minus level. So so not all the places are above the elevation, above the zero elevation. So now I think it's easy for you to understand this problem. Uh, so that is the that is uh, the the point on the topographic drawings. So now please use your pencil and use your hand, use your pencil and use your paper to draw this one, and draw this uh, uh, to practice how to write down, how to present point points and his elevation. So now please draw this. Please draw this. It's very simple. It's very simple, but it's a basic knowledge for next point. Okay. 2 minutes. 2 minutes for you to draw this.
Okay.
So everybody, please use your hand. Please use your hand and draw this. To draw this strip. There's only 3 points with his name and elevation. It's not so hard. Okay, so I think all of you will finish this task. Uh, okay, so let's go. Okay, let's go on with so we have learned the where is how to draw the photographic of a point, and how about a line? You can imagine that in a space and if you draw a line between 2 points, you get a segment. Okay. The first one, representation. So if you draw a line between A3 and B4, now you can get a way. You can get a way to represent the lines about on the topographic drawing. And for example, this one is A3. A3 means this is a point names with A, and its light region is 3. And here is same. The name is B, and the elevation is 4. And this one is the same. So please stare at this line of this line. You can see the C3 and D3. So what's its meaning? So who can tell me what is the feature of this line? So this line is horizontal, is vertical, and also it is maybe in other position. Who can tell me? This position with the plane with the sea level. Who can tell me this?
Should you repeat the question again?
Repeat the question again.
Yeah.
Yes. So now you can see this point. This point's elevation is 3, and this point's elevation is also 3. So what is the relationship between this line with the sea level plane?
The distance of this line from sea level is 3.
This line is the elevation of 3. Yes. Okay, and how about the relationship? I mean, is vertical or horizontal or oblique?
This is horizontal.
Yes.
Horizontal.
Yes. Okay. Fine. Very nice. It's a horizontal line. It's a horizontal line. With the It's a horizontal line with the sea level, because this point, the start point and the end point, has the same elevation.
Yes.
Yes. Okay. So it's nice. Okay. Oh. Okay. So now let's learn something more complex than before about the slope or inclination and the slope. So now you can see this finger. Here is this point is A and this point is B. The difference of the elevation is H. So now you can see the A and the B's elevation is not the same. The A is lower and the B is higher, and A and B is a line. Is a oblique line. Is an oblique line. It is not vertical to the sea level, and also it is not horizontal to the sea level. Okay. So let me ask you, so how to represent the position of the A and B. So you can see this line has an angle. Here is an angle, and how to let me see how to say it. Sorry. So how can we get the degree of the of this how of this line's inclination? So we have to use the concept of slope. The slope is the height divide the horizontal distance. So you can see h is the difference of these 2 points in elevation in vertical direction and L is the difference of the 2 points in horizontal direction, and so we can get the slope called I, and is equal to tangent A, tangent theta A. So now if the h is much more bigger and the L is keeps the same, so the I is bigger. So you can see like this or like this. So that is the slope. That is the slope. And if we use the L divide H, it called the L. It's called the L. It is means the if we use L divide H, it is the L. For examples, if a line at A its elevation is 7.3 and the next point is 3.3 and the L this distance is 12. So let me calculate the slope I is the difference between A and B in vertical direction, and divide L, and is equal to 1 to 3, 1 and divide 3, and this one is 1 divide 3, so it is 3. Okay, so so please calculate if a line is here. If a line here is A, B, C, C, and his elevation is 15, and here is the D, point D. Its elevation is 12. It is 20. Is 20, and its distance in the in the horizontal direction is 5. So please tell me the line CD. Please tell me the I. of line CD. Okay, so please do it. Please do it, and we can have a rest. Have rest for 10 minutes, and please do it for 2 minutes, and we will come back at the 11 and 10. When you have rest, and you can think about this question, and I hope you can give me the answer. This point, C point, with its elevation is 15, and D is 20. So the horizontal distance is 5. So please tell me the slope of this line.